Every time you flip a light switch, there's this massive, invisible machine that springs to life. But have you ever wondered how we get that power, not just reliably, but also in the most efficient and cheapest way possible? Well, that's the billion-dollar question we're diving into today. Answering this, well, it's a huge, real-time puzzle that grid operators have to solve every single minute of every single day. It's this constant balancing act, right, between keeping costs down and obeying the hard laws of physics, all to make sure the lights stay on for all of us. So to even start solving this puzzle, engineers began with a really simple idea. Just imagine the entire power grid is one giant, perfect piece of metal. They call it a copper plate, where electricity can just flow from anywhere to anywhere, instantly, with no rules and no limits. Now, in this perfect copper plate world, the solution seems pretty straightforward, right? You just fire up the cheapest power plants to get the job done. And this very simple, cost-focused idea has a name: economic dispatch. Economic dispatch, or ED for short, is really about one thing and one thing only: money. It's basically a big calculation that tells every power plant exactly how much juice to crank out so that we meet all the demand while spending the least amount of money on fuel possible. In this simple model, we're not even thinking about how the power actually gets from point A to B. So how does that work? It's actually pretty clever. To get the lowest total cost for the whole system, you don't just run your cheapest power plant at 100%. The system hits its economic sweet spot when the cost to produce just one more little bit of energy is exactly the same across all the generators that are currently running. And that cost for the next little bit has a name, too. It's called the incremental cost. Think of it this way. If a power plant is already working really hard, making that one more megawatt hour is going to be a little more expensive than if it was just coasting. Economic dispatch is just the process of balancing these incremental costs across the whole grid. And this isn't just some good idea. It's the actual mathematical key to finding the cheapest way to operate. When every generator is humming along at that same incremental cost, you know you've found the most economical solution. But, and this is a huge but, we're still living in that perfect imaginary copper plate world. So, what happens when this simple, elegant idea smacks headfirst into the messy real world? Well, as you can probably guess, things get a whole lot more complicated. That simple economic dispatch solution runs into some very, very hard physical limits. Yeah, spoiler alert, the grid isn't a magical conductor. It's a real physical web of wires and transformers and switches. And every single one of those components has a breaking point. You just can't shove an infinite amount of power down any old wire you choose. The laws of physics kind of have a say in the matter. And ignoring those laws? Whoa, does it get expensive. Just look at this number, a staggering $2.1 billion. That was the cost of just grid traffic jams, congestion, in one single power market in the US for just 1 year. This is the kind of cost that shows up on our bills when reality bites back. So what are these real-world headaches? Well, for one, power lines can literally get too hot and start to sag if you push too much electricity through them. Voltage levels have to be kept in a super tight, safe range. And the electricity itself has to follow the basic rules of physics, like Kirchhoff's laws, which decide where power actually flows, not just where we wish it would go. Okay, so this is where our second, much more sophisticated hero enters the story. To manage a real grid, you need a tool that speaks both economics and physics. And that tool is called optimal power flow. Optimal power flow, or OPF, takes that same cost-saving goal from economic dispatch, but it adds this absolutely crucial layer of realism. It still tries to find the cheapest way to make power, but, and this is key, it does it while making absolutely sure that none of those real-world physical limits get broken. This slide right here, this really gets to the heart of the whole thing. Economic dispatch is asking a simple question: what's the cheapest way to make the electricity we need? But optimal power flow asks a much bigger, much more important question. What's the cheapest way to run this entire system without anything blowing up? I love this way of thinking about it. You can almost write it out like a formula. Optimal power flow is just economic dispatch plus all the messy, complicated physics of the actual power grid. It's the grown-up version of the problem. So how does this actually work behind the scenes? Well, an OPF calculation usually starts with the answer from economic dispatch, that theoretically cheapest plan. Then it's like a stress test. It checks that plan against all the physical rules. And if it finds a problem, say an overloaded power line, it starts carefully tweaking things. moving away from that absolute rock-bottom cost, just enough to find the cheapest option that is also safe. Let's make this super concrete. Imagine you've got a really cheap power plant way out in the country and a more expensive one right next to a big city. Pure economic dispatch, which only cares about the price tag, is going to scream, crank up that cheap rural plant to the max. But OPF, because it understands the whole network, sees a problem. It knows that plan would overload the power lines going into the city. So it makes a much smarter call. It says, okay, let's dial back the cheap plant just a little bit and have the more expensive city plant pick up the slack. It prevents a blackout, it keeps the system stable, and yeah, it costs a tiny bit more, but it's a price well worth paying. So, understanding this difference, it's not just some academic thing. It is absolutely fundamental to how we keep our lights on and our bills as low as possible in the modern world. So what's the final verdict here? It's pretty clear. Economic dispatch gives you the cheapest answer for a perfect theoretical world. Optimal power flow gives you the cheapest answer for the real world, the one that actually gets power to your house safely. You know, this quote from our source material just nails it. Economic dispatch is the foundation. Once you really get that basic idea of minimizing cost, then OPF is just the next logical step. You're just adding all those layers of real-world physics on top. And this all brings us to one final really big thought. Our power grid is changing, fast. We have more and more solar and wind, which are unpredictable. That makes this balancing act for optimal power flow way, way harder. So the real question for the future is, how do these essential calculations need to evolve to keep up with an even more complex and dynamic grid?